trying to get enough lines clear that we can see it go to the next level. I think we'll have enough. Let's see. Yeah, there we go. So we've moved on to level 2. We have 10 lines in the next level, and we have 1,000 points. So yeah, looks like it's all working together. So yeah, I guess I should stop playing Tetris. Hey, have you ever wondered how to make a Tetris game? Well, in this video, we're going to look at building Tetris using JavaScript and React. Should be a really good chance to learn quite a bit about React and also go through making a fully functional game. I'm David, and I'm going to get us started. So we're going to start this Tetris build from scratch, and first we should just get a game plan together. So here you can see that we have a Tetris board and kind of all the normal things you would expect in a modern Tetris game. And if I move through this, you can see here I've just kind of labeled some of the parts we're going to need. So we're going to need the board, which is where the actual pieces get placed. We're going to need a player, which is what's going to control where the Tetromino pieces go and keep track of some other information. Eventually we're going to need the ability to move the Tetrominos left and right and rotate and do slow drops and fast drops. And part of that will be displaying this what's called a ghost down here, like a preview of where it'll do the fast drop. We'll need something to actually contain all this stuff, calling it Tetris here. And then we'll have the previews of the upcoming pieces for the player in the top right, as well as some stats about the game in the bottom right. So to get started, I've just loaded up a new project in CodeSandbox. And what we're going to do here is we're going to create a new sandbox. And in this, we're just going to pick React as our template. And this is going to give us a new project. And you can see over here on the right, we have a preview. In the middle, we have our code. And on the left, we have our list of files and dependencies. So the first thing we're going to need to do is we just want to kind of remove some of the styling defaults. And we want to introduce a style for our app. So the first thing we're going to do is just kind of do a little bit of resetting here. So we're just going to set for everything the margin and padding to be 0, and then use box sizing border box. And I apologize, this isn't going to be a CSS tutorial, so I'm just going to be putting in some of these values, and we're going to use white as our color because we're going to have a dark background, so we're going to want anything that appears to appear in white. And then our background is going to be kind of a purple. And the editor here will give you some color picking tools if you want to use those and play around with what color you're using. And we're going to set the height to be 100 vertical height, which is going to take up the full browser there. And then we're going to add some padding as well. You can add as much or as little of it as you want. And then we're just going to save that. You'll notice as we're making changes here, it's just going to auto update, but you can still save your changes. You notice a little dot here is showing that it's not saved, so I'll save it. Now it's saved. And then at any point, if you want to download the project, you can just do export to zip here. So yeah, anytime you want to get your files, you can just do that. And so now we've got just the basic styling in for the app here. And this is fine. We'll just, for now, just kind of get rid of that. And then the next step we're going to do is we're going to add some more folders within source here. So we're going to want a few folders. You can either right click and do create directory or use this icon here for new directory. And we're going to want a business logic folder. You might refer to this as like a utils folder, a components folder. And then also we're going to make a hooks folder, because we're going to be writing a number of custom hooks. And in a React project, there's different ways you can handle organizing your components. Just for simplicity, I'm going to keep all the files for the components in this components folder. But you may want to do something like create a separate folder for each individual component and all of its files. So next up, we're gonna add our the beginnings of the game. So I'm just gonna go ahead and make a game component here, assume we have it. And the things we're gonna want are rows, because we wanna know how big the game should be. And you could hard code this, but I like having the ability to change the game from the outside if we want to. So you'll notice here over on the side it's complaining because we don't yet have that component defined, and we'll do that next. So up here we'll want to do import game from, and then it'll be /source/components/game. And you don't need to include the JS in the end, it'll figure that part out. And as long as you have a default export, you can reference the game this way. If you wanted to export with by name, you can do it this way. For components, I always assume there's only the component that's going to be exported, so I usually just do it that way. And then in here we'll make a file called game.js. And then for now, we're gonna do kind of a simple thing just to make sure that it's working, and then we'll kind of layer more stuff in as we go. So we want a constant called game, and what gets passed in here are the props, so that's going to be anything that you have listed here for the most part. And you can just destructure this so you can directly reference those things by using the curly braces, and then you can do rows and columns. And then whatever we return from here is going to be what gets rendered. So we could, just to see it work, we could do something like this, and we should see the right side actually render. What's it complaining about? Oh, I gotta export it. Sorry. Okay, so here you can see it's rendering. So whenever you export default, that allows you to do your import like this. If we exported this constant as a named export, then we would want to do something like that, because you could be exporting more than one thing and you need a way to reference it. So yeah, cool. We've got our game being output there, and now we could just make small increments on this to show that it's working. So if we wanted to, we could do well, eventually we're gonna have some logic, so I'm just gonna go ahead and wrap this in a body, and then we can just do return, and this should do the same thing. Okay, and then now what we're gonna do is just add some things in here, so we can say rows, and then if we do curly braces in here, we can reference those values that we passed in. So now we can see that there's 20 rows over there, and we should see 10 columns when we put the columns in. So yeah, you can see those values that we set over here are getting passed through, and we'll just go ahead and save both of those. And then this is kind of cool, but it's not really what we need, but we'll go ahead and add a class name on here for game. And now you can see we're still outputting this information here, but now we have a class name that we can use. Ultimately, what we're going to want here is a button that's going to say start game, and then if the game hasn't started, that's what we use. And then if the game has started, then we actually want to render a board here. So what we're going to want is like a menu, essentially, that we can show here. And then when we're gonna want to give it some kind of something to react to when you click on it. So we could call that start And then just for now, we can do a log just to show that we've clicked on it. And then we'll just say on click on that button is going to be that start function. And just be careful, you don't want to call the function here. You want to just pass the function, so that way the menu can just call it. If you call it here, it's going to evaluate and then pass that as the onClick, and that's not what you're going to want. And then you can see over here it's complaining that we don't have a menu yet. So what we're going to want to do is we're going to import menu from source components menu. And again, it's going to complain because that's not found. So we're going to need a new file, and that's going to be the menu. And then we're going to do a very, excuse me, a very similar thing in here. So we're going to say const menu equals, and then we're going to have an on click. And then at the end, we're going to want to export default menu. And then for now, we can just do, just put something in here to show that it's rendering. And now you can see over here on the right that we're rendering the game, and then the game's rendering the menu. And then within the menu, we're going to want to make that look a little nicer. So we're going to say div class name is menu. And then we'll close that div out. And then we're going to want a, I'm going to change this from, a technique you can use is just to either, whenever you're going to return just JSX or HTML basically, you can just leave the curlies off, or you can use parens like that. But I'm just going to leave the curlies off. It looks a little nicer. And then we're going to need a button. So we'll say button is class name. And we're also going to give that a class name. And then its click is going to be the on click that we passed in. And we're not going to want that to self-close. We want some text there. So we're going to say play Tetris. And so now you can see we have a button on the right that says play Tetris. And it looks a little funny because we stripped off all the margin and padding for every element in our app file. So we can just go back and style that the way we want it to look. And what we'll need for that is a CSS file. So we will do import menu.css. And the CSS files should always be siblings to the components, at least with kind of the vanilla setup with React. So that's why I'm going to use a relative path here. So this just means look in the same location as this file, and then pull up menu.css. And then we will add a menu.css. And in our menu file, I'm just going to copy some styles I've already written over, but I'll explain them as I bring them in. So for the button, I want to add a lot of padding because I want to make it really easy to click on it. And then I want to make the text a little bit bigger, so I just increase the font size to be double our default font size. And then I wanted a nice border radius, and I didn't want a little black border around the like 3D looking border around the button, so I did border none. And then just gave it a bit of a shadow so it stands off the background, and then changed the cursor to pointer so when you hover on it you can see the pointer. And then in our menu, I'm setting that up to be display flex, and then using that to center the button. So we're gonna justify content center, align item center, and then I wanted to give it a height and then also a z-index to make it stand off of the background some. I think the min height is affecting the layout. Let's see. Yeah, so that's just gonna make this appear a little bit lower so it's not jammed up against the top there. So we'll save that. And then save that. And you'll notice when you're working in CodeSandbox, it's got some linting set up and I think prettier rules so that when you save, it'll auto format your code. So don't get too carried away with trying to format things manually, because when you save, it's just going to enforce some coding standards. And then you notice as we're going, we're getting a lot of errors down here. And some of this is just from like errors from typing as you go. So I like to clear these out occasionally. So we're going to clear those. And then if we click on this, now we should see console logging start down here in the bottom. And it'll just get a little number next to it that increments each time we click on it. So we know that our on-click is getting passed through successfully, and we can use it here with play Tetris. So at this point, we've got a basic placeholder game in and a basic menu in place. And we actually want something to happen when we click on play Tetris. We basically want to be able to switch to the game once we hit play Tetris. And to do that, we need to know whether the game is started or not. And the way we're going to do that is we're going to add some state to the game. And we're going to do that using a custom hook. So what we want is we want to be able to say, we're going to get a game over Boolean. And we want a way to set game over. And we want a way to reset game over. And we're going to use game over. And this is just like what you're gonna call this is what we're gonna call our custom hook here. And it's complaining because we haven't written this yet, so we're just writing kind of what we want, and then we'll go in and actually implement it. So we're gonna import useGameOver from source hooks useGameOver. And then again, it's gonna complain because this file does not yet exist. And then down here, we're gonna go in and we're gonna say, give us a useGameOver hook. And then within here, what we're gonna need to do is set up our useGameOver hook. And we're gonna want to get game over and set game over. And we're gonna use state for this. So now we're taking advantage of React's useState. And to use that, we're gonna need to go up here and import useState from React. And there it should start to calm down a little bit. And then another thing we're gonna wanna do is we're gonna wanna set up a reset game over. And we're gonna wanna make sure this thing only gets executed when we want it to get executed. So we will use useCallback. And then we don't want it to get like repeatedly called. And then we're gonna, when someone calls reset game over, it's gonna call set game over false. And what's nice about that is it's allowing us to update the state just within functions that are inside the hook. So we can kind of control all the state in one place. And then we're going to return game over, set game over, and reset game over. Oh, oops, I messed up here. This should just be game over. So this is going to be the actual value, and this is going to be the setter. And that's what you get when you call useState. You get a value and a setter. And then whatever you pass in here is the initial value for the value. So in our game, we want it to start it's basically a game over, like not have the game playing immediately. So we'll set that to true. And let's see, what is it complaining about here? Oh, we need to include useCallback as well up here. Yeah. All right. So now we have useCallback. And then useCallback, you'll also need to pass it any dependencies for when you want it to update. And we don't want it to update, so we're just going to give it an empty list of dependencies. And I think we should be good there, so we're going to just save that. And then what we can do now to test this out is we can go back to our menu. And it looks like we don't need to change anything there. And then if we go to the game, we can look at what should be printed when you do start. We're going to say start, and then we're also going to include the game over value just to show that it's how it's changing. So we'll say game over is game over. And that way we can see what that value looks like. Let's see, what's it complaining about here? Oh, yeah, so we're gonna get some complaints as we're doing this from CodeSandbox that there's things that there's values that we're pulling in that we're not actually using at the moment, and we will get around to using those. So I'm just gonna leave those in for now. So if you see these yellow squigglies, that's probably what those are gonna be about. So now that we've updated our button here, we can do play Tetris, and it's gonna say game over is true. And then it's gonna keep saying it's true when we click on it. And that is because we need to have the start function instead of just doing the console log. What we really want it to do is to reset game over. And that's gonna be using this function that we returned here. And so now when we click on it, we should see start game over is false. So by clicking on that, we've changed this default value of true to false. So now we have a way to say that the game is not over and that we actually want it to do something. So now that we have a way to turn the game on and off, we're going to want to go in and update our game to display something different when the game is started. And the way we're going to go about doing that is we're going to use that value that we just created. So down here, we're going to say game over. So when the game is over, we want to render one thing, and when the game is not over, we want to render something else. So when the game is over, we want to show our menu. And when it's not over, we want to show Tetris, right? And we're going to do a refresh on this. So here you can see we've got play Tetris, and then when we click on it, we have start game over is true. And then now we're seeing Tetris up here. I think this output's weird because of the way the state resolves in React. So we're just going to kind of ignore that for now and update the code to just call reset game over. It's not really helpful at the moment. We can see that Tetris is loading because the value changed. And then we'll just clear this stuff out again. And we're gonna go ahead and make a component for the Tetris game. And this is really gonna be more of a smart component or something that kind of like coordinates a set of components and some state. But I'll go ahead and just get that started. So what we're gonna want with it is we're gonna need also the rows. So we're gonna just pass those along, and we're gonna want the columns as well. And then we're gonna want set game over. And then we'll just go ahead and close that out. And you're gonna see it's complaining because it doesn't know what Tetris is because we just haven't defined it yet. So we will do import Tetris from source components and Tetris. And now it's just complaining that it can't find the module, which is expected. And we will make a new file called tetris.js. And here we're just going to set up something basic to start with. So we will do constant Tetris. And then again, we're going to destructure all those parameters that we were passing. So rows, columns, and set game over. And then we're going to do an export default for Tetris. And then for now, we can just paste that same thing in that we were doing earlier. Actually, we're going to need to say return Tetris. And now we're going to clear this out. And then when we hit play Tetris, again, we're seeing Tetris. So we know that this is kind of set up the way we want. And then we're also going to want to use this as a container that a bunch of other pieces of the game can use to kind of be positioned. So part of this is we're also going to want to add a tetris.css. And what we'll do in there is we will just set up .tetris to have position relative. And what that's going to do for us is, now that we have this container that has a relative position, if we position anything within it absolutely, it's going to be positioned absolutely relative to this container. And that'll let us kind of position things a little more easily as we go. And then I'm just going to do another clear and see how that looks on the right. And then from here, what we're going to want to do is we're going to want to start building out all the things that we want to actually display on the screen. So we've kind of got a container for the game, and then this container we're going to use to return more information about the game. So we don't actually just want to output this Tetris thing. We can start with just doing simple versions maybe of each thing we're going to care about. So we're going to want a board. And for now, I'm just going to set up a board here. And a board's going to be... It's going to be an array of rows, and then those rows are going to have some values. So we'll take a look at that in just a second. For now, we can just do that. And then it's going to complain because we don't have a board component, so we'll have to make another one. So we'll say board is equal to, or sorry, is imported from /components /source /component /board. And it's complaining now because we don't have that component, so we'll just make it. And then we'll do the usual thing again. So we're going to set up constant board is equal to this function. And then at the end, we're going to export it. And then again, for now, we can just return something like board. So now when we click on that, you can see we're kind of drilling down through these components, but ultimately app returns game, game's going to return Tetris, Tetris is going to return board. And then what we're going to want is an actual board with values that we can use. And the way we're going to get that is we're going to create a hook for it. So we're going to say, let's put our hooks down here below these. So we'll say import use board from source hooks use board. And again, this is trying to make sure that we keep our data and data management as separate as we can. So we'll save that, and then it's complaining because we need a hook. So we'll create a use board hook, custom hook. And then for now in use board, all we really want is to return the kind of initial board setup. And the way we're going to do that is we're going to set up our hook. Right now we only have we really only have rows and columns. Eventually we'll have more stuff that we're concerned with. And then at the end of this, we don't have to do the export default because we're already exporting this from here. And then in here, we're going to want to set up our board. So we're going to say board and set board equal useState. And then we're going to want to send in some kind of initial value in there. We're going to get complaints because we need to import useState from React. And then basically what we'll want to do is just build the board in here and return it. And I'm going to make our first utility for doing this. So up here in business, I'm going to create a new file that's called board.js. And inside of that, we're going to create a little function for building an empty board. So basically what we're going to want here is to, I'm just going to paste in some code and I'll talk through it. But what we want to do is we want to take the rows and columns. We want to make an array for the rows. And then for each row, we want to make an array that represents the columns. And then in each column in our board, we want to set up a default cell. We'll look at that in just a second. And then eventually we're going to return a board, and a board's going to include rows, and that's the rows that we built up here, and then a size, which is going to include the rows and the columns. So we could do like board.size.rows, board.size.columns, and then also board.rows. And then here we have default cell, and this is just representing the default cell on the board. And we're going to do something similar. We're going to set up a file under business called cell, and that's going to include the definition for our default cell. And our default cell is just going to track what the class name is for that cell, and that's going to correspond to a piece, an individual square from one of our tetraminos, and then whether the cell's occupied or not occupied. Because essentially, the board's a collection of these cells, and as a player, we're moving our tetraminos down, and then whenever we're just passing through cells, they're not going to be occupied. But when we actually have a collision and we want to keep track of that, we basically stamp the piece that we're using onto the board cell, and we track what that piece was that we stamped by using class name here. So that is our default cell. And then here it's complaining because we have not imported default cell. So we will import that. And sorry, just a second. And we're going to import that from source, business, and cell. So yeah, so at this point we have a way to build our default board. So we can come back here. And then instead of using this empty array, what we're going to do... sorry, give me just a second. what we're gonna do is just call the function that we just created. So we'll say build board with rows and columns. And it's gonna complain because we don't have access to that hook yet. So we'll say import build board from /source/business/board. So now it's not complaining because we have all this stuff available to us. And then at the end, we're gonna actually just want to return board and set board. And for now, we're not actually going to use set board, so I may just leave that off of there. And then we'll just save that. We'll go back to board. And then within board, what we're going to want is we're going to want to actually get the board. And for now, we can just do a console.log of board. And we're going to get a complaint because we're not actually passing in a board at this point. So we need to go back to where the board's being rendered, which is here. And then what we'll do is we'll actually build the board to send through to the board. So we'll say const board and set board is equal to use board. And use board needs rows and columns, so we'll pass those in. And then what we want to do is we want to pass the board through to the board. So we'll save that and let's see what we get now. So you can see when we rendered the board that we got this output down here, and it includes the size of the board, which has rows and columns. And then we have an array of 20 rows, and then each of those rows has 10 objects in it, and those objects are all the default cell. So we were able to build the data representation for the board, pass it through to board, and then have it render out at least the data for the board at this point. And next up, we'll look at actually rendering a board. So let's take a look at that. So what we're gonna want to do is, instead of just dumping out, sorry, where are we? I need to pull up the right component. Instead of just printing out the text for board, we actually want to output our board here. And the way we're gonna do that is we need to do a couple things. We need to output all of the cells for the board, and we also need to set up some custom styles. So we'll do the styles first. And basically what we're doing is, based on the board that we get, we want to look at the total rows and columns, and we want to set up a CSS grid that represents evenly sized cells for each of those slots. And we have to do that dynamically because we don't know how many rows or columns we have until we get the board and we see the board size. So that's why we're making these styles in here. And then the next thing we need to do is we need to loop through every single cell that we have. And the way we'll do that is down here, we're gonna return a board div, a board with a class, a div with a class name board. We're gonna include those styles that we created up here. And then we're gonna, for each row on the board and for each cell within that, we're gonna want a board cell. And for each of those board cells, we need to provide a key, a unique key. So we're just gonna generate a key that is the basically the cell, the number of the cell that we're in. And then in addition to that, we're going to pass in the cell. And so in our case, these will be those default cells that we created in our hook, or sorry, in our build board. So we're just setting all of the cells initially to be this default cell. And then you'll see it's complaining now because we don't actually have a board cell. So we need to create that. So we'll get rid of console.log for now. And then up here, we need to do import board cell from source components board cell. And we're gonna get a complaint that that's not found because we haven't made it yet, and that's fine. So now we'll make a board cell. And within that board cell, we're gonna want our CSS. I'm gonna start moving a little faster just because I assume you're kind of following these patterns. So we're gonna want some CSS to style this. But the board cell is going to take a cell, and for that cell, it's going to make a div with a class name of board cell, and then whatever the class name is for the given cell. So by default, that's just going to be nothing. But what we'll do is we'll use that. We'll change this value so that we can visually differentiate the different types of tetraminos that we've placed by their styles. And then within this, we want a little bit of visual appeal. So we're going to add this little sparkle, which is going to give us a little circle in the top left corner to make it kind of look shiny. And then the last thing that we're missing here is we just need to make our board cell CSS. And I accidentally made our board cell in the wrong place, so I'm going to move it. Actually, let me double check. Yeah, it's a component, so sorry, I need to move that into components. And so now we're able to import our CSS for board cell. And we're actually gonna have quite a bit here. I'm gonna bring over it piece by piece, but for the board, we want it to get centered. We want to round off the corners a bit, and we're gonna also do position relative. We might be able to remove that at this point but I don't know. What this will do is if we position anything within the cell, we can do it absolutely, which is kind of helpful. And then eventually we're going to want, I'm going to look ahead a bit, but eventually we're going to want to represent tetraminos. And regardless of which one we have, we want it to be kind of rounded. So, and we want it to be shiny, kind of lighter color on the top and darker on the bottom to have a bit of shading. And then we had the sparkle in our board cell, so I'm going to go ahead and pull this in. So if we have sparkle within tetramino, and we could probably even just get rid of this, we're not going to have other kinds of sparkle. We want to position that absolutely within the board cell. And then we're basically just going to make a little white circular highlight. So that's what the border radius is, making that circular. And then this is looking ahead slightly, but I'm just going to go ahead and bring all these styles in while we're here. So you can see here we have a different kinds of tetraminos we're setting up. So when we have the ghost one, we don't want that sparkle to appear, so we're going to get rid of it. And then these styles down here are going to be what we use for the individual different pieces. So the eye piece is like the long column, and we're going to want the background color on that to be this bright blue. And then each of the different pieces we're just going to want colored differently. So that's why those are set up that way. So now we should be able to see what we've done here. I'm going to clear out everything on the side, and we're going to hit play. And it looks like we're just getting one little sparkle up here in the corner. Let's see what that's about. So let's inspect this and we can see what's going on. And so we've got our app, we've got our game, we've got our board, and we have a lot of board cells. And the board cells look like they're all just stacked up. Maybe that's a consequence of not namespacing. Oh, sorry, not namespacing this. Let's see. Let's see what we get now. Okay, so now we're kind of getting nothing, which is interesting. So I think what might be going on is we might be missing board styles. Yeah, okay, so we're just missing board styles. So we're gonna wanna create a board.css. And here's the styles we need for the board. So again, we want a grid, and we want a little spacing in the grid, and we want it to be twice as high as it is wide. That's something we might want to set dynamically, but for now that works. And then, yeah, we're just setting up some background, border radius, and shadow for styling. And then over here on the board, we need to actually import all of that. So we'll do import board.css. Cool, and now you can see we do have our board. And if we were to right click and inspect this, this should, yeah, give us an individual cell within that board. So you can see we have a lot. There's going to be like 200 cells in total because we have a 20 by 10 board. But this gives us a good start. So we have a place to kind of start working. And I think where we'll go from here is looking at building out the other little elements that can be displayed over here on the right. So now we're going to look at adding the other things that we want to display along with the board. And what we're going to do is we're going to return from here a div, and that div name is going to have the class name Tetris, and that's just matching our component name. And then we want to actually render this board within this Tetris div. So there's our board again. And then the next piece we're going to want in addition to the board is the game stats. So we'll just assume we have a component here, and we'll give it the game stats, assuming we have some game stats. And then we're going to get a bunch of complaints that game stats is not defined. And so we'll start with the component. So we'll say import game stats from source components game stats, and then that doesn't exist, so we need to make it, and we will do game stats. And in game stats, what we're going to want to do is, I'm just going to copy some code over for the sake of time, is we're going to want to import React because we're going to want to memoize this so it doesn't render over and over. And then we're going to want some styles to be imported for how this looks. And you can see it's complaining about that. Let's go ahead and just fix that. So we'll make a new file that's gamestats.css. And here we're setting up the ability to have game stats that appear either on the left or the right of the board. Right now we're only going to use them on the right. And these are just positioned absolutely. They have a fixed width. It's a list, so we're going to get rid of the list styling so we don't have little dots that show up. And then we're going to give it a background, we're going to give it a color. This is the default color. And what this is going to do is it's going to make the labels like a little transparent, 50% transparent. And then for the actual values, those are going to be fully opaque, so they're brighter and they're a little bit bigger as well. And we'll hop back over here. And so what we've done is we've made a game stats component. It takes game stats and it's going to pull off a bunch of different attributes from game stats. It's going to destructure those. So we'll want level, points, lines completed, lines per level. And then we'll want to set up how many lines we have until the next level by subtracting the lines per level minus the lines completed. And then down here, we're actually setting up our markup. So we've got that GameStats class. We've got the GameStats _ write class. And then we just have a list here that has kind of each piece. So there's level, there's the level value, there's lines to level, line to level value, points, and the points value. And then we don't need this thing to update unless the GameStats have updated. So we're just going to use react.memo, and that's going to keep it from rendering every single time. It's only going to render when GameStats actually change. So I'll go ahead and save that. I'm going to close these two out. And then when we come back here, we still got a complaint because GameStats isn't actually defined anywhere. And we just want to take care of that next. So what we're going to do is we're going to go ahead and create our GameStats. So we want GameStats, and we're going to want a way eventually to add lines that were cleared. And that's really the only change we need to make to GameStats. So I'm just going to go ahead and put that in there for now. And then again, it's going to complain because we don't have a hook for that. So it's not actually getting any values. So we're just going to make another hook. So we're going to say use GameStats from use GameStats. And now it's complaining because it can't find the file, which is fine. So we'll make it. Say use GameStats.js. And in here, I'm just going to copy some things in for speed. So what we're going to want to do is we're going to want to export use GameStats. And this doesn't require any information, so we don't have to pass anything in. And then what we're going to do is we're going to say we need state. So we're going to say we want GameStats and set GameStats from useState. And then similar to what we did with the board, we're going to do a build GameStats. So we're just kind of separating the logic for building the stats from the hook itself. And we could make a game stats business object and move this out. It's so simple for now that I haven't done that. And then for now, I'm just going to make an add lines cleared. Well, we won't use this until later. And we're not going to have it do anything for now. Just going to define it. We'll revisit that later on. And then we're just going to return from here game stats and add lines cleared. And you'll notice we're not returning set game stats, and that's kind of intentional. Like, there may be times when you need you want something outside of the hook to set the data up, but generally it's better to just provide like individual methods that do that can be called like add lines cleared from somewhere else and then handle the actual changing of the state here, so it's all in one place. So we're going to save that. And then over here, everything's starting to look good. So if we hit play Tetris, first I'm going to clear out our errors just so we know. Yeah, we're going to accumulate some problems down here that are just related to not using things that we've returned, but we will use those things eventually. So you can ignore those for now. And there we go. You can see we have stats that are appearing next to the game, and as we kind of resize things here, you can see that they're kind of sliding around with it. So cool. I think that's looking pretty good. So now we have a board and we have game stats, and the next thing we're going to want to include is the previews of the pieces for the player. And this is going to drive pulling in a number of things, but what we'll do is we'll just go ahead and assume we have a previews component, and we're going to pass to it the tetraminos, and those are going to come off of the player. So we're going to say player.tetraminos, and then that's the only things that we need for that. And you can see this is going to complain here that we don't have many things set up. We don't have a player set up, so it's undefined, and we don't have the component. So we'll start just by making a component. So that will be, oh, excuse me. This is going to be previews, and we're going to want to pull that in from previews. And just temporarily, we can set up a player here. You can say const player is equal to this object, and tetraminos is an empty array or something. And that'll just get rid of that error. We're gonna fix that at some point. And then we need to make a new component here that's previews. And then for previews, this is going to be pretty basic. This is another component where we only want it to render occasionally specifically when the data changes. So we'll be using React useMemo for this. And I'm just going to paste in the code for this and I'll talk through it. So again, we want React because down at the end, we're going to want to use react.memo when we return the component. And this is the component here is previews, and it's going to take the tetraminos. And then with the tetraminos, we don't want to look at the one that the player is actually using at the moment. So here's where we just process the tetraminos that we were passed so that we only show the ones that the player isn't currently using. And then in addition to that, we're going to return all of separate previews for each individual tetramino. So we're going to take this object that we built here, or this array that we built here, and then we're going to map over it. And for each tetramino at a given index, we're going to render a preview of that tetramino with an index value, and also have a key. Anytime you map over something like this, you need to provide a key. Ideally, you don't just use an index for the key, but I don't really have anything else unique that I can use at the moment. And then you can see it's complaining because we don't actually have a preview component, so we'll make that next. And anytime I have like a list, I generally like to break a component out for the list and then the individual things that are being listed within it. And then for the preview, this one's gonna be kind of long, and I'll talk through it. And this is gonna require us to kind of pull in a bunch of different things. So what's going on here is we need some styles. So you can see it's complaining that we don't have those, so I will pull in those styles as well. And what we have is we need a way to like position where these are going to appear. So this is just setting up kind of a starting point. So we're going to start towards the top, and then we want to start left of the board. Or we want to push from, we want to show it up right of the board. So we're setting a left that has a pretty high value. And then we want this to just have a little bit of a background and a border radius, so you can see the entire potential space that's occupied by the tetramino. And then this is setting up a board that's very similar to the Tetris board, and it's a grid display with a gap of 2 pixels, and it's going to be a 4x4 grid, and it's going to be quite a bit smaller than the board. And this is arbitrary. You could size these to be whatever you want. I've made them a little bit smaller than the actual pieces that appear on the board. And then over here in the preview, essentially what we're doing is we're gonna build the board, and the board's gonna be the thing that we're actually gonna display the piece on within the preview. And then we want to be able to transfer the tetramino that we're currently dealing with to the board so that it can display. So we're going to import board cells because we're going to reuse that. And then here's our preview. So for each tetramino and each index that we get, and that's coming from here. So each time we render this thing, we care about the tetramino and the index. We're going to look at that tetramino, and it should have a shape, and it should have a class name. And then for the preview, we're going to build a board that's 4 rows by 4 columns, and this is going to give us this grid in here that's 4 by 4, and that's where we can stamp our tetramino or transfer our tetramino. And then we need to position the tops of these depending on which preview we're rendering, so they don't all overlap. So that's why the style here is dynamically setting the top so that it increases for each preview that we render. And then we're going to want a way to say for the previews board, we want to transfer the tetramino that we are using to the board. And then down here, we want to actually render that preview. So here's the kind of container for the preview. Here's the board, the container for the board. And then here's the actual board getting rendered. And this is very similar to the main Tetris board that we're using. So we're looking at all the board's rows, and for each row, we're looking at all of the cells. And then for each cell, we're going to render a board cell, and we're going to give it a unique key, and we're going to give it that cell. And then the board cells are already set up to take advantage of the class name information that we're going to provide for each tetramino. So all of this is in place, and the only thing that we're missing at this point is going to be transfer to board. So over here under business and board.js, we're going to add a function here that will transfer a tetramino to the board. And give me just a second, I'm going to find that. Actually, I apologize. Instead of putting it we could put it in board, but I think what we're going to do instead, we're going to add that function to a tetraminos business object here. So we'll go ahead and fill this out a little bit because we'll need a few things from here. So first off, we're going to do the one we were just looking at, and this is what we were calling from preview. So we want a way to pass a class name, whether or not the space on that board is occupied, what the position is within the board of the shape. For us, it's just going to be 0, 0 because we're not worried about like a larger board. And then the number, or the actual data for the board, that's what rows is. And then the shape, which is the tetramino's shape. I'll show you that in just a second. And then basically what we're going to do is, given that shape, we're just going to go through each cell, and then we're going to look at each row for the shape, and then for each row we're going to look at each column, and that's basically going to have a cell. And if it's occupied, or if there's something there, we're going to start setting up these values. So we're just going to track whether it's occupied or not, given what was passed in. We're going to set the Y and the X position to be the position plus the current row and column. That's how these are going to be set up. So this is basically taking whatever the position is that you're starting on within the board. In our case, it's 0, 0, and then adding the position of the shapes cell. And then with those, we know where to place the item in the board. And so that's what we're doing here. We're saying for the rows for the board, for the Y-th row in the X column, we want to set an object up that's whether it's occupied or not, and what the class name is. And this is the cell information. So if we go over here, you'll notice default cell has occupied and class name. And then what will probably make this easier to understand is if I actually bring in the tetraminos. So I'm just going to go ahead and bring all those over. So the tetraminos, we're going to have a bunch of them, and these have names. So I is the one that's basically a column. And so for I, the shape is going to be a set of rows, and then each row is going to have 4 values for columns. And you can kind of see visually here, anywhere there's a 0 is basically dead space, and then anywhere there's a 1 is where there actually is an object. And so here you can kind of visually see I is like a column, and then here you can see J is kind of shaped like a J, or like a mirrored L, and then here L looks like an L. And then so each of the shapes is going to have, or sorry, each of the tetraminos has a shape and has a class name, and the class name is going to be tetramino, and then also tetramino __ whatever the shape is. And those map back to our board cells. So over here, by doing that, we're going to pick up, for I, for example, we'll pick up the background color for I, as well as this styling, because it also has the tetramino class, and also like the sparkle. So in tetraminos, we've got all of the different tetraminos, and now we have the transfer to board. And we're also going to want a way to return a random tetramino. So I'm going to go ahead and bring that in too. And to do that, we're basically just going to take the keys for all of the tetraminos. So this is going to be like T, Z, I, J, S, and save those as our keys. And we're going to generate a random number from the set of up to like the last index for the keys that we have here. So that's going to give us an index. And then here we're going to say out of these keys, find the actual key at the index position. So say, for example, it came up as like T. We would end up with a key of T. And then within tetraminos, we can just look up T. And then that'll give us a random tetramino. And then we'll go ahead and just save that. I think we have most of what we need there. And kind of bubble back up to here. So here's where we actually need to set up real tetraminos to pass into these previews. And right now we just are setting up kind of an empty array. So we need to fix that. And what we're going to do is we're going to set up another bit of state that we want to be able to use. So we'll get rid of this. And what we have here is we're going to create a custom hook called usePlayer, and it's going to give us a player, a way to set the player, and a way to reset the player. And then we need to add that up here as well. And this is just where we're going to store the data for the player and manipulate it. And let's see. And now it's complaining just because we don't have that hook. So we'll create the hook. So we're going to say use player. And so now we're going to do a process that's very similar to what we already did in the other hooks. So in this hook, we're going to need to set up a few things. Sorry, give me just a second. So basically, we're going to want to eventually export this usePlayer hook. And what that's going to do is it's going to get some state. It's going to get the state, the player state, and a set player setter through useState. And for useState, we're going to provide the values by using build player, which we'll fill in here in a second. Then we're also going to set up a reset player, and we only want this to get called when we're intentionally calling it. So we're going to like use useCallback here, and we're going to take the previous value for the player and pass it to build player, and that's going to let us just update the things that we keep some values from the previous player and then update the things we want to update. And then we're going to return all this information down here. So we'll return the player, the ability to set the player, and then this reset player function. And then in order to build the player, we need a few things. So we're going to want to set up these tetraminos. So we'll go ahead and set that there. And then eventually what we want to do is we want to return a bunch of data. And by default, that data is going to be saying that it's not collided, that we're not in a fast dropping mode, which is something we'll look at a little later. And then we need a position. So by default on the main board, the position is going to start in the first row. So that's row 0, and then in the middle, and that's column 4. We're going to want tetraminos, and then we're going to want the current tetramino so that we can reference it directly. And we're just going to get that by popping it off the tetraminos. And then we need to actually build up the tetraminos. So what we're going to do is, if we don't have a previous, so if this is our first time coming through, we're just going to make an array of length 5, and we're going to fill it. And then we're going to, so this will basically be an array that's like 0, 0, 0, 0, 0. And then for each of the elements in that array, we're going to map over them and just create a random tetramino. And then down here, we pop off the one that we want to use. So I guess technically we have 4 previewable pieces. It'd be interesting to check. May want to bump this down from 5 to 4, but we'll see. So yeah, basically build player is going to be responsible for building up the initial version of the player, as well as being able to update the player in the future as it changes. And then we're just calling that from in here so that the state that we use uses whatever was built from here. And now if we come back over here, we should actually see previews. We may get errors. Let's take a look. We'll clear this out first. And there we go. We've got our pieces lined up here. And I'm kind of interested to see, I think we could technically get one more piece previewed there. I'm going to try bumping this down to 4 and see what happens. Let's try this again. Yeah, I think there's a mismatch in the algorithm somewhere. But anyway, we can see that we do have our previewed pieces appearing on the right, which is great. And you'll notice at smaller sizes, these things kind of bunch up. But if we were to spread this out a little more, they'd kind of resolve. So one thing we could look at in the future is just like scaling all these stats down here so they're not quite so big, that they're more like, their size is more like a percentage than like a fixed size. But yeah, so that gives us a good start. So now we have our player. We're actually generating our previews for the player off of real data. We have our game stats and we have our board. So what we can look at next is figuring out how to actually incorporate the player with the board. And what we'll do is we'll hop over to Tetris, and you can see in use board right now, we just have rows and columns. And I'm actually going to move these around so they're the board comes after the player. And we're going to want to pass in some more things to the board. So we need a player, we need a way to reset the player, and we're going to eventually want a way to handle lines being cleared. But right now, really the thing that we're going to be using the most is this player that we're passing in. So I'm going to go ahead and save that. And then under use board, we're just going to want to mirror the things that we've passed over. So it's going to be player, reset player, and what was the other one? Add lines cleared. So save that. And then we're going to need to do a bit more here. So what we're going to want to do is anytime player changes or reset player or add lines cleared changes, we're going to want to update our board. And we're going to use a useEffect for that. And down here, we're going to have a useEffect. And then anytime one of these pieces of state changes, player, reset player, or add lines cleared, we're going to update the board. These things shouldn't change, but they're technically a dependency because we're going to use them in here. So we have to include them. But within our useEffect, we're going to say set board. So we want to update the board. And we want to be able to look at the values in the previous board as a starting point. And then we're going to call a function called next board. And we're going to provide as the board whatever the previous board was. And then whatever the current state of the player, reset player, and add lines cleared is. So basically anytime player changes, we're going to call set board, and we're going to create a new board starting with the previous board and the player, essentially. So we'll save that, and then you'll notice next board is not defined, so we need to define that. And then we'll go up to board. And we're going to define this a little bit at a time. I'm trying to simplify from the completed version. But basically we're going to want to export this function here for next board. So it's going to take board, player, reset player, and add lines cleared. We're also going to want to access the tetramino and the position from the player. So we just go ahead and grab those there. And then we want to go through each row on the board, and we want to say for each row, for each cell, is that cell actually occupied or not? And if it is occupied, we want to keep the value for the cell. So you can imagine this is like there's a couple scenarios. So if it's occupied, that means we've already placed a piece there. So we don't want to lose what piece we placed, so we keep the cell. If we haven't placed a piece, we just want to clear it out, basically. And we do this because, like, as the player is moving through the board, we're showing the piece in these cells as it moves down. So as we move, as we go, the piece drops a row, we want to clear out, what was behind it. Because if we don't do that, it's just going to leave a big trail, and it's going to look like a paintbrush instead of a Tetris piece. So here's where we clear everything out. And then the next thing we need to do is actually update the rows to include the piece. So we're going to do transfer to board. And this is the same thing that we used in the previews earlier. So here we're going to say we want to transfer to board. The class name we want to use is going to be the tetramino's class name. And then whether it's occupied or not depends on the current state of player.collided. And we'll worry about this later when we get into collisions. And then the starting position is going to be the player's position, which is what we pulled off up here. The rows are going to be the cleared out, kind of the cleaned up rows that we've made up here. And then the shape that we're dealing with is the tetramino's shape. And just to kind of jog your memory, we can take a look at tetramino's transfer to board. So all this is doing is it's saying, like, given a board and given a shape and given a starting position, transfer all the individual components of that shape to the board. And then we want to track whether the cell that we're creating on the board is actually occupied, meaning we've had a set collision there in the past. And then we also want to set the class name so we know what it should actually look like. So we'll go ahead and save that. And then what else do we want to do? I think at the moment, all we really need to do is return this actual board. So let's see what that looks like. See if we can render the kind of player's starting position. So on the side here, we'll do play Tetris. Okay, and we have a problem. Let's see what that's. Oh, I know what that's from. So we'll go back to use board. So you can notice just from this error over here, we're calling set board, but when you look up a couple lines to useState, we're only grabbing the value and not the setter. So we need to go back there, and we're just gonna add set board. And anytime you use useState, you get a value and a setter, and that's all this is doing, is it's just getting the value and the setter. So let's do this again. Okay, so now we're getting a complaint about transfer to board. So let's take a look at that. And that is in board business board line 23. So it doesn't know what transfer to board is. And let's see, do we not export that? Oh, I'm sorry, I'm pulling it from the wrong place. So it's not in cell, it's from somewhere else. So we'll say import transfer to board from Tetraminos. Now let's try that. And there we go. So now we can see the piece that we're starting with is just going to appear up here at the top. If we refresh this, we could hopefully see a different piece. So that's good. So now our pieces are appearing. So congratulations if you've made it this far. I think this is actually really great progress. So at this point, what we have is we have a Tetris board, we have our Tetraminos, we have a player, we have the ability to show the player on the board, we have these previews, and then in addition to that, we have some game stats down here below. And you know, if you think about this kind of like you're making a board game that's controlled by a robot, we're at the point where we have all of kind of the pieces that we need to be controlled, and we have some of the basic logic in place for you know, how to get the values for all these pieces and the state that we're going to want. And now we're kind of looking more into how things get controlled and then how the automated parts of the game are going to work. And once we've kind of got all that in place, we can start looking at things like player movement and input, and start getting kind of the basics in place for moving things around. So at this point in our Tetris game, we've got the player, the board, the previews, and the stats. And now we're getting ready to do some of the more advanced things. And just specifically, we've kind of handled most of these things. We have a Tetris game, we have the board, we've got all these different things that I'm pointing to here. So now we're pretty much ready to look at the movement. And just as a refresher, the way that the player is set up in this game is that the position's represented by this big white dot up here. And that dot is controlling a shape, and the shapes are a 4x4 grid. And within that grid, only the spots that are occupied by a piece are going to be like marked as occupied. And then what's going to happen is we move the player around. We're going to want to be able to go left, and we're going to want to be able to go right. We're also going to want the ability to like drop down. And then as we move left and right, like, we don't want to stop when the white dot gets to the edge of the board. We actually want to be able to go past that because we want this tetramino shape to be able to hit the edge of the board. And if we stopped at where the dot is, we would always have this gap on the left. And then similarly, when we go right, we don't want to stop when this dotted border hits the edge. We want to keep going because there's an empty row here. And then that same thing is going to apply as we move down, where we're going to want to just keep moving until the actual tetramino piece is going to run into something. So we can't just compare the player position. We need to actually look inside this shape and see if the parts of that shape have collided with anything. So we're going to start kind of moving in the general direction of player controls, but we're going to start with something more basic. We're just going to try to get a quit button that works. So this is going to drive a number of things in the game, but what we're going to do is we'll make a game controller. And that game controller is going to take a lot of things. So it's going to take a board, and it's going to take game stats. And the reason it's going to take a lot of different pieces of information is because this is really kind of the heart of the game. So as you're controlling the player, we're going to need to consider all these different things. Okay, and then we'll need to close that off. And then we're getting a complaint because we just don't have a game controller component. So we'll want to go ahead and create that. And so we'll go up to components and we'll make a new one. And we're going to call that game controller. And our game controller is going to have quite a few things. We're going to start with kind of as basic of a one as we can get away with. So I'm going to say const game controller equals, and then we need to give it all those things that we were passing in earlier. And I'm just going to copy those because there were enough of them that it'd be easy to forget some. So we need a board, we need game stats, we need a player, we need set game over, and we need set player. And we're gonna need commas after all those, except the last. Okay. And then we're gonna wanna export default game controller at the end. Oops, sorry. And then eventually what this is gonna be, it's gonna just be an input. So we're gonna wanna have an input. And for now, let's not have any key up or key down or any of this stuff. We'll just render something onto the screen. And then we also wanna have some styling for this. Sorry, I'm gonna move this down here for now. We'll take a look at it in a second. We need some basic styling. So we'll say import game controller.css. And this is pretty much just an input starting out. So we'll do game controller.css. And then eventually what we're gonna want to do is hide this input like off of the screen. But for now, I'm just gonna leave this out of here. We'll come back and look at that in a minute. So let's just go ahead and render this and see what we get. It's complaining because game controller is not defined. I probably haven't imported it. So let's import it. So what we're trying to do is we're just trying to get an input where we can capture key presses. So you can see down here we have this input, and you'll notice by default it's not focused. We'll have to like click into it to get it to do anything. See how it's got the focus ring on it? So what we'll want to do is come back to the game controller. And we want to automatically focus it. And sorry, so what we're gonna do is we're gonna return this input, and we're gonna go ahead and just add all of these things to it. And you'll notice it's complaining that there's no key up and key down. So we'll just make a quick placeholder for each of those. And for each of those, what we're gonna want is, we're gonna wanna grab the key code. And then with the key code, we'll do whatever it is that we need to do. But just to kind of test this out, we can do a log, and we can do key on, key up, and then we can do the code. And then same thing over here, we can say on, key down, and then the code. And let's see what we get. So now that we have that autofocus attribute on input, you'll notice it's focused by default. And then now if we press up or down, we should get some different things logged. So let's try that. So up, so you can see on key down, we got arrow up, and then on key up, we got arrow up. We'll see duplicates for all these. So I'll do key right, key left, key down. Or sorry, I meant the arrow. So I'll do arrow up, arrow right, arrow down, arrow left. So cool. So we're getting what we would expect for all of those. And then if we do things like press Q, we're going to get key Q. And I think what we'll want to start with here is just something basic. So the first thing I think we'll do is just have Q in the game so that you can get back to the menu. And we're gonna kind of jump through a bunch of steps to get that working. But let's go ahead and start on that. So what we could do is we could write something like if code is equal to key Q, then set game over to be true. So we'll try that first. There's just a simple initial way to do it. We'll start a new game, and when we press Q, we go back to the beginning. And you can just keep doing this back and forth if you wanted to. Now, the problem with this is we're gonna get a lot of different keys that we care about, and we're gonna wanna react to them. And we're also gonna end up with these names like key Q or arrow up, showing up anywhere we care about what key was pressed. And this will quickly become kind of spaghetti code here if we don't get ahead of that. And another thing we might want to do is, like, if we don't get a key that we recognize as like a valid input, we may just want to completely stop and not try to do anything. So a way that we can go about doing that is we can start to just go ahead and set up kind of an input manager for us. And I'll show you what that's going to look like here in a second. So really what we want to get to is we don't really care about the code equaling key Q. What we really care about is getting the action based on what was pressed. So what we'll want to do is just get rid of this here, And it's kind of an intermediate step we can do this. So we can say if action is equal to action dot quit. And that way we kind of convert, we make an abstraction, so we go from just caring about strings that come in as from key codes to converting it to like an action, a semantic action within our system that has a meaning that we care about. So this is the quit action. So if we have an action that is the quit action, we're gonna quit. So you'll notice this isn't gonna work. We're gonna get errors because this doesn't exist yet. So we'll go ahead and set that up. So what we're gonna do is we're gonna create another business object, and we're gonna care about what the actions are. We're gonna wanna be able to get an action for a key. And then that's gonna come from, we have to make this, but it's gonna come from source business input. So we'll save that, and then it's gonna complain because that doesn't exist. And we're gonna make an input file. And basically what we're gonna wanna do is we're gonna wanna take the keys that are pressed, we're gonna wanna map them to actions. So here is an object for like key codes, and on the left are the actual like strings that we're gonna get back based on the event from the input. And then we're gonna wanna be able to look up in those keys based off the key code. So that's what action for key is. And then we're getting a bunch of errors because actions aren't defined. So actions are gonna be, basically, they're just gonna have strings that match the keys for now, but this is gonna allow us to compare against action.left and action.fastDrop and that kind of thing. So what's nice about this is in one place in our program, we've got the keys we actually care about, we've got the actions we actually care about, and we instantly translate to kind of semantic meaning so that we know we're trying to rotate, we're not trying to key up. So if we hop back over here, we should be able to see if we refresh this that we can do a queue, and it's going to quit the game. So it's doing that translation for us right here. So when the key goes up, it's going to call, it's going to get the relevant action, and if that action is action.quit, we know what to do about it. And that's a decent start. So we're not worrying about actual kind of input that affects where the player is, but we do have something set up to handle input from the keyboard. And we could go ahead and just, with this game controller, uncomment this. What we should see when we do this is that you don't see that input, but if we hit Q, it still takes you back. And that's the way we're going to leave it for now. If we start having trouble, I may display it again, but for now I'm just going to hide that input off of the screen. So now that we have some basic input, now we're going to take a look at actually affecting the player through input. And the way we're going to do that is we're going to make a way to control the player. So we need a new function here, and it's going to be handle input, and it's going to take an action, and we're going to pass that action along to a player controller. And it also needs to know, the player controller also needs to know about the board, the player. It needs a way to set the player and a way to set game over. And what we're going to do is, right now this isn't defined, that's why it's complaining. But ultimately what we want to do is call handle input from here, and we want to pass it the action, And again, we're going to need to do this translation from the key code to an actual action in our system that means something. So I'm just going to go ahead and save that. And then we need to get the player controller, and we don't have that yet. So we're going to go ahead and assume we have it, and we're going to include it up here. So we're importing player controller from source business player controller. And that means we need to make a new business object here called player controller. And some people call these utils. I tend to refer to them as business objects. If we were doing TypeScript, they would correspond to things you can do with these types. But for now, all we need to know is that we've got a new file under business called player controller. And this is going to get quite complicated as we go. And I think for now, a good place to start is just focusing on rotating a piece. So we'll get started there. And what we're going to want to do is we're going to want to export this player controller. And again, it's got an action. It takes an action, a board, a player, set player, and set game over. And then if we don't have an action, we can just do a return immediately. And then what we can also say is if the action is equal to action.rotate, we want to actually try to do a rotation. And you'll notice I call this attempt rotation. I didn't call it rotate. And that's because we may not actually be able to rotate. So if you have functions like this where the outcome is uncertain and you're not actually going to do the thing you're requesting, I always try to give a hint with a name that it may not actually do the thing you're trying to do. And so here we have attempt rotation. And then you can see here it's imported automatically for us, but I'm just going to go ahead and give it the full path to that, because we care about action here. So that's why that's pulling that in. And then now we need to look at doing the rotation. And this is going to be a little complicated, but what we'll want to do is we'll want to get rotate. Sorry, we'll need a rotate function in Tetraminos that can rotate our Tetramino. And then we'll want to actually try to do this rotation. So we need a function here for that. And so here I just set up attempt rotation. It's gonna have to take into account the board and the player, and then the ability to set the player or not. So like if we can do the rotation, we need to update the player through set player. And then what we're gonna wanna do is we're gonna wanna try to rotate, assume we can rotate. We're gonna wanna create a shape that is the rotated version of the player's Tetramino's shape. And again, that is corresponding to one of these. So the player is going to have a Tetramino that looks like this, and then it's going to have a shape that looks like this. So if you imagine rotating an eye, what we really want to do is make the second column the second row. So we want to take all the values here and we want to fill out the second row. And that's basically what the rotate function is going to do, is it's going to transpose the rows and columns. So we'll hop back over to player controller. So assuming we're able to get that shape, what we're going to want to do, we're also going to want the player's position. And then we need to check if what we did is a valid rotation. So we're gonna set a Boolean here for isValidRotation. And we need to check two things. We need to see if we're within the board still, because it's possible to rotate a shape so that part of it's sticking out of the board. And then we also want to make sure it hasn't collided with anything. So if you imagine if we had like the eye piece, like the column, if we had that horizontally down here and we rotated and then it shot through the bottom of the board, we don't want to allow that to happen. So we need some checks for those things. And then if it is a valid rotation, assuming we have all that information, we want to update the player with the new Tetramino. And then otherwise we just want to return false because we were not successful. So here we're saying if that was a valid rotation, we're going to set the player to all the values that were previously on the player. And then for the Tetramino, we're going to update it with the everything that was on the Tetramino and then the new shape. So the new shape is the rotated shape that we define right here. And so now we need to go and provide implementations for each of these functions. And the way we'll do that is we'll provide a rotate shape for Tetramino. So I think we may have pulled that in earlier. I'm not sure. Okay, it looks like we have not pulled that in, but it's relatively straightforward. So in here, I'm just gonna copy this over, but what we need to rotate is a piece in the direction that we're rotating. And for our game, we're always gonna kind of rotate clockwise. But you could, if you wanted to, you could provide the ability to rotate in either direction. And then essentially we're gonna transpose the rows and columns. And then depending on which way you're rotating, you may want to also like flip the shape around. And that's what this code's doing down here. So that'll give us our rotated piece. And then we'll go back to our player controller. Actually, I'll save that and we'll go back to our player controller. And then now the pieces that we're missing are the checks to see if we're within the board or if we have collisions. So we'll grab those. And both of those are going to come from board, because those are more about the board than they are about our controller. So we're going to just assume these exist. So we'll import them from has collision and is within board. And we're going to get those from our board business object. And so over here, now we need to provide implementations for those. And we'll start with is within board. And what we'll want to do is we'll want to take a board and a position and a shape. And what we'll do is for that shape, we'll go through each of its rows. So we're grabbing a row, and then we're going to go through each of its columns. So here we're just grabbing the given row and looking at how many columns it has. And then we want to do this check. This is important. We want to also check to see for the given row and the given column if there's a piece of the Tetramino at that position. And just as a reminder, for like, say for example, for the T shape, what we're doing is we're looking for these ones. Like we don't want to look for collisions where there's zeros, because you can get in a situation where like maybe the bottom of the T is off the board, but it isn't actually a collision until this part runs into the board, the bottom of the board. So what we're doing here is just only checking where there's ones. So I'll go back to board. And then what we need to do is any place we have an actual Tetramino piece, or like a piece of the Tetramino, we need to look within the board as well. So now we need to take the column of the piece and add to it our current position, the column that we're currently positioned in. And then we're going to say, is this a valid position? And the way we'll do that is we will look at in the board for a given row, for the given column, is there anything in there or not? And then if it's not a valid position, we're going to return false. So this is basically making sure we're not outside the board. So like, you know, if we're looking in row 25 and that doesn't exist, this would immediately become invalid. If we're looking at column like 40 and we only have 10 columns, that would immediately be invalid. So in those cases, we would just return false. And then if we make it all the way through and all the positions are valid, then we know we're within the board. So we can return true. And just as a refresher too, this is this whole problem here that I was talking about where we can't just check the player position represented by this big white filled in dot. We have to check like all these spaces to see if they're within the board or not. And then the other piece that we need is we need to check if we actually had any collisions. And this is going to look very similar. And I'm gonna add this whole function here and I'll just talk through it, but it's going to be quite similar. So again, we're going to take a board, a position, and a shape, and we're going to say the same thing. So for a given row in the shape, and then for a given column within that, is it occupied? Does it have like a 1 in its position? And if it does, we care about the column. And then we're going to say, if we have a row and we have a column and that's occupied, then we return true, because you can't have two things occupying the same space. And then otherwise we're going to return false. And there's probably a way you could combine these so you're not doing the same loop twice. But it's simple enough that I kind of like to keep them separate. The tetraminos are only ever going to have 16 total indices to check. So even though technically this is processing the tetramino twice, they're so small it kind of doesn't matter, at least at the moment. It's not a big deal. So I'm just going to go ahead and save that. And then if we go back to our player controller, we should see that all of that is valid. So now in our player controller, if the action is action.rotate, we can attempt this rotation and everything in here looks pretty good. So we will go ahead and see if that works. And I'm just going to refresh this just in case. And so now I'm going to press up, and you can see as I'm pressing up, this piece is just rotating clockwise. And if we had changed the direction the other way, it'll rotate the other way. We could probably take a look at that. I haven't even tried it. Let's see what it looks like. I may not like it. Yeah, so now we're rotating counterclockwise. But I'm just going to change it to rotate clockwise. I think that's the more typical behavior. So cool. So now we have, well, you can't see it with a square, but we have the ability to rotate clockwise. I guess I'll just do it one more time so I can prove it to you. So here we go. We're rotating around. And we can quit. We can still quit. So now that we have piece rotation working, we can look at doing some player movement, and that'll reuse a lot of the same pieces we already have. This is going to take us on a little adventure. It's going to be quite a bit of code, but hopefully it'll be understandable. So what we want to do now is, if we don't have a rotate action, we're going to come down here and we're going to assume we're trying to move. So we're going to say attempt movement. And again, the reason we're saying attempt here is because you may not actually be able to move. So we want to indicate that with the name of the function. We don't want it to be a mystery when the player doesn't actually move. So we'll say attempt movement, and what we're going to need is to make a function in here that handles that. So in addition to attempt rotation, we're going to need attempt movement. That's going to take all the things that we just discussed, and we're going to need to drop down to the next line. See if that short, yeah, there we go. We want those to kind of stack up. And then what we're going to do is, the way to think about the movement is we want to capture the delta. So we want to see like how much somebody is trying to move. So we'll start off assuming no change. So our delta is going to be moving by 0 rows and 0 columns. And then eventually we're going to care about this thing called fast dropping. So I'm going to put that in there for now. But we basically just want to clear that each time we go through. And then based off of each different kind of action for movement, we're going to do different things. So if we are fast dropping, we just want to note that. That'll come in later when we want to drop the pieces all the way down quickly. Otherwise, if you're pressing down, that's going to translate to a slow drop action. And in that case, we're just going to add 1 to the row. So the rows start at 0 and count up as you go down the page. So when you drop, you're going up a row. You're going up, the index is going up by 1. And then if you go left, you're moving, your index should lower because you're moving to the left. So, and then if you move to the right, you want to add 1 to the column that you're in. So the top left is 0, 0, and then the bottom right is going to be 20, 10, essentially. So you're counting up as you go down into the right. And then what that's going to do is give us the delta. So at this point, we should know how much someone is trying to move, and that's going to be represented by the delta. And then we need to make sure here we're gonna try to move the player, and we're gonna get back from this function whether we've collided with something and then what our next position should be. And we haven't written this yet. We'll take a look at this in a minute, but we need to give it the delta. So this is how much we're trying to move. We need to give it a position, which is going to be our current position as a player. And then we need to let it know what the shape is, because we always have to take into account the grid for the shape. So that's going to be our current Tetramino's shape. And then we also need to give it the board so that it can compare against the board and see if that's an allowable move. And then assuming we have all that information back, what's going to happen is we're going to decide, we need to update whether we need to do something with the information. So if we collided and the player's position is in the very first row, we just want to immediately game over. And so if we have a game over, we want to set the game over. And then otherwise, we're going to do a set player. And we want to include all the original values from player. And then we want to update this with the new collided value, the new is fast dropping value, and the new next position from move player. And when we update that, that's going to have all the state that we need set on player, so that when we come back into rendering the board again, that it knows where to render the player after it's been moved. Now the other thing we need here is an actual move player function. And we're just going to define that above attempt movement so that it's available. And we're going to need all of the information that we discussed earlier about what was passed to it. So we're going to need a delta, a position, a shape, and a board. And then again, we're going to want to look at where they're trying to move, because we're always looking ahead. We want to see where the player's trying to go and then do something based off of that. So we'll create a desired next position that's going to be the player's position row plus the change in row, the delta row, and the player's positions column plus the delta column. So that's going to represent where they're wanting to go. And then we need to find out a few things. We need to say, assuming they go to that position, is there going to be is that a collision? So we pass in to has collision, the board, and the desired next position and the shape. And then we also want to check to see if we're still within the board. And these are very similar to the things that we use for attempting rotations. So we want to know whether we've collided, we want to know whether we're on the board. And then we need to do a few things with that information. So we want to prevent you from moving under different circumstances. So we're going to set up prevent move, and basically if you're not on the board, we don't want to allow that to happen. We want to make sure that your entire Tetramino piece is within the board. Now that's not the same as a player position, because again, the player position can go outside of the board to the right or to the left, but that actual piece we need to make sure is within the board. And then we also want to prevent the move if you're on the board, but you've collided. So those are the conditions for when we want to prevent you from moving. And then based off of whether you're allowed to move or not, we're going to get your next position. So if you're not allowed to move, you're just going to stay where you were. So if prevent move, we're just going to return your old position. But if we're not preventing the move, then your next position is the one that you're trying to move to, the desired position. And then we also need to keep track of if you're moving down, because that's important for collisions. So here we're saying if your delta row is greater than 0, that means you're trying to move down the board. Because remember, as you're moving down the board, you're actually going up in rows. And then, so if you are moving down, we want to say if you're moving down and you've either collided or you're not on the board, we want to count that as a hit. And a hit means your shapes actually run into something, and we want to stamp it into the board, and then we want to kind of like reset you to the top of the board with a new piece. And then at the end, we need to actually return some values here. So we're going to return your next position, and then whether you've run into something or not. And I think that should give us what we need. Let's just make sure when we come down here that everything looks okay. So again, what we're going to do is we're going to pass the action to this player controller. If the actions rotate, we're going to try to rotate. If it's not, we're going to try a movement. And then when we attempt a movement, we're going to say how much are we actually trying to change. Initially it's 0, 0. And then we also will care about fast dropping, so that I've just included that here. But basically, if our action's a fast drop, we're just gonna mark it as a fast drop. Otherwise, we're gonna look at whether we had a slow drop, move left or move right, and we'll update the delta. And then we need to try to move the player. We need to pass that delta, the current position, the shape, and the board. And based on all that, we need to see whether we had a collision, and we also need to see what our next position should be. And then if we're off the bottom of the board, it's game over. Or sorry, if we're off the top of the board, I should say, it's game over. Because we shouldn't have collisions in the first row. And then otherwise, well, yeah, in all cases, we want to update the player with the previous player attributes, and then an updated value for collided, is fast dropping, and position. And by setting the next position, next time the board's rendered, the player will be rendered in the correct position. So let's give that a shot. So I'm going to move this over here a bit. And now we should see if we can move left and right. So there we go, we can move left and right. And I think we can also drop down. Yep, so we can move the player down. So now we've got movement. So this is pretty cool. We're getting a lot closer. If I can still rotate up. And if I go left, I should not be able to go off the board. And if I go right, I should not be able to go off the board. And then we'll see what happens when we hit the bottom. So it's considering it a collision, you'll notice. So we hit the bottom, and that's actually good. The thing that's not good is it's not resetting our player to the top of the screen when that happens. So we might want to take a look at why that's happening. So we have this little issue here where when we're at the bottom of the board, we're not resetting the player to the top of the board when we have a collision. And we can just fix that pretty easily by inside of board.JS. When we're doing getting the next board, we can say if the player has collided or they're fast dropping, we want to reset them. Now, it might be possible to move this into the use player hook, and that'd be something interesting to look at later. But for now, we're just going to include this here. And then I'm just going to do a quick refresh over here. And we'll just see if when we manually hit the bottom, if we get reset. And there we go. And this is looking a lot more like a Tetris game at this point. So we can actually play this. It's not going to do auto dropping, and we're not going to get scoring and lines clearing and all that kind of stuff. But this actually feels pretty decent. Got all the basic movements in here. So we'll go ahead and stop playing. It's tempting to just keep playing Tetris, so we'll stop. And I think the next thing we may want to look at is actually doing the automated drops. And then we'll actually need to do the system for allowing the pieces to fall. So that'll include the manual slow drop that goes one square at a time, or fast drop that just drops the piece to as far as it can go, as well as an auto drop that happens every 1 second and kind of gets faster throughout each level. And anytime we do one of these drops, we'll want to reset the timer so that you get the full allotted time before the next drop happens. Because if you don't do that, what can happen is you could be about halfway through the timer pretty easily, or even almost all the way through it. And when you move the piece down manually, it immediately moves another space. So we don't want that to happen. So now we're going to take a look at automated drops. And we'll start really simple, but it'll get kind of more complicated as we go. And one thing we're going to need is a hook that was created by Dan Abramov. And sorry, just a second. I'm trying to get set up here. Cool, yeah. So one thing we're going to need is a hook written by Dan Abramov called useInterval, and this is just a safe way to use timeouts with React and have them behave the way you would expect. So I'm just going to import that here. And then we need to actually bring it in. So we're going to put that in our hooks. And that is useInterval. And I'll just bring that over. And this is doing some magic to allow us to use set interval nicely. and not have it interfere with the way React works. I don't know the details. I'll see if I can find an article that explains it in depth, and if you're interested, you can take a look at that. And then, yeah, back in our game controller, what we're gonna do is for now, we're just gonna set up a basic value for this. So we'll use an interval of 1,000, and each time we hit 1,000, this is in milliseconds. So every second, we're gonna call handle input with this action slow drop, and we can just see what that looks like here. And so what this is doing is just using everything we've already made and simulating a user input pressing down. And you should see that when we hit a collision, when we have a collision at the bottom, that we just reset and get a new piece at the top. And you can also see that the pieces are updating over here. So like when we drop the square, we're gonna get an L piece, and then we'll get a column next, I piece. So again, this is starting to feel more like Tetris. We'll want to get a little more sophisticated in this because we'll want to control the drop speed, especially as we progress through levels. And then we'll also want to make sure that, like, if you press down, imagine you press down right before the drop was about to happen. What could happen is you go down a square and then immediately go down another square. And so instead of doing that, what we want to do is anytime you intentionally move the piece down, that we reset the auto drop timer. So that way you get a full second, like after you've moved down, before it moves down again. So we can't just use this simple value here for drop time. So what we'll want to do is we'll want to set up our own drop time. And we're gonna start that up here. And what we want is, we want to get a drop time. We want the ability to pause the drop time and resume the drop time. And again, we'll make a custom hook called useDropTime. And we're gonna pass to it game stats, because as we level up, we want to adjust the drop time. And then down here, we'll want to use the drop time that we get back. And then you'll see it's complaining because we haven't created drop time yet. So we'll say use drop time, and then use drop time. And it's complaining because it doesn't exist, so we'll just make it. So we have use drop time.js. And what we're going to want in here is drop time. It's going to take in some games. Excuse me. It's going to take in game stats. And then eventually we're going to need to return drop time, pause drop time, and resume drop time. And in order to make these things work, we're going to actually need to hold on to two different values. We're going to need the current drop time and like the previous. And we're also going to want to set some constants up here. So our default drop time is going to be a second. It's 1,000 milliseconds. The minimum it should ever go is 100. It's 1/10 of a second. And then our increment per level is going to be 50, because as we go up in levels, we want to increment we want to make the game move faster. And then we're going to use a bunch of different things provided by React up here. So we're going to use state, use callback, and use effect. And then, as I mentioned, we're going to want two different sets of two different uses of useState. We're going to want the current drop time and then the previous drop time. And we're going to initialize the current drop time to our default. And then we've got this previous here. So this is basically going to allow us to handle pausing and unpausing and being able to retrieve whatever the value of the drop time previously was, instead of just going back to a default value, which could be much slower, especially as you get further in the game. And then to resume drop time, actually I guess we should look at pause first. To pause drop time, what we're going to want to do is when drop time changes or set previous drop time changes, we'll want to call this, and then if either of those change, we'll also need to call this. But so when we do pause drop time, if there is a drop time, we're going to set previous drop time using the value of drop time, and then we're going to set drop time to null, and that's just going to pause it. So we won't do auto drops. And then we need a way to resume drop time. So what we'll do is, again, we're going to use useCallback, so this just doesn't get called over and over and over. And then we have to add the dependencies here, so this depends on previous drop time. So if we don't have a previous drop time, we're just going to return. And then otherwise, we're going to set drop time to previous drop time, and then we're going to set previous drop time to null. So if we want to resume, we're just going to copy the value from previous if it exists, and then we'll always just clear out previous drop time by setting it to null. And then finally, at the bottom here, we're going to do useEffect, and if GameStats.level changes or set drop time changes for some reason, we want to call this function. So what we want to do is we want to update the speed. So basically, we don't want to update the speed on the very first level. That's why I'm subtracting 1 here. But for every level beyond that, we want to add the speed increment. And then what we want to do is we want to start with the initial drop time, and then we want to subtract whatever our current speed is from that. So, you know, essentially we start with 1 second is the amount of time you have for the drop, and then as the levels increase, you have less and less than a second, 50 milliseconds at a time. But we also need to be careful that this doesn't go to, you know, close to 0 or negative, because we do want you to have a fighting chance. So there is a minimum drop time of 100 milliseconds up here. And then with that new drop time, we set the drop time. So anytime that our level changes, the speed's going to automatically get updated for us. So we'll go ahead and save that. Excuse me. And then now what we can do is, when we have a key up, actually let's go the other way. So we have an action for pausing. So what we can do down here is we can say, if our action was pause, if you have a drop time, pause. So that if you have a drop time, it means that we're dropping. And if we don't have a drop time, we want to resume. So this is basically pause and unpause all in one action. It just depends on what the current state is. And then otherwise, we're just going to quit, or otherwise we're going to handle the input. We can also move this out of here. I don't think it should be in there. And we can move it here, so we can say else. Actually, let's put this one, yeah, let's put it here. Else if action is equal to quit, we want the game to be over, and then otherwise we want to handle input. So if we play this now, we should be able to do P. So I think P is pause. Let me see. Yeah, so I hit P for pause, and you notice the piece is no longer moving. Now it might respond to input. Yeah, it does. But if we unpause, it's going to keep dropping. So we have pause and unpause now, which is good. And then yeah, we may actually just want to return to when it's paused. I think if we added a return here, then we wouldn't be able to move the player when it's paused. Let's see. Ah, I'm wrong. Anyway, we worry about that issue later. But yeah, now we have a way to pause and unpause using the drop time. The other thing that we should do is pause the drop time when we think you actually have a real input. So down here, if we're dropping, we want to pause the drop time. If the action that we're using as a drop, we want to pause the drop time. And then when the key goes up, we want to resume the drop time. So when you've stopped dropping, essentially, we want to resume. Now you notice we don't actually have this function for action is drop, but we can get that here quickly. We can make that. So this is going to come out of input. So we're going to say action is drop, and then we'll go back to input. And in input, we're just going to make a simple function that we can export from here. And it's just going to say, given an action, is it either slow drop or fast drop? And again, this is keeping logic about our inputs consolidated into one place. And then we'll go back to our player control, or sorry, our game controller. And I think we're looking pretty good. So we'll do play Tetris here. And I'm gonna wait until a little bit after the piece is moved and then try to move down. You should see it waits another full second. Yeah, so it's not, if we didn't have that delay in, it would just automatically, in a lot of these cases, just move down. So it kind of looked like it's moving two squares and feels like a bug. It doesn't feel right. So it's one of those things that's kind of it seems very minor, but it's very important to the game feel that you're in control, that you don't get surprised by it like jumping ahead on you. And anybody that's played Tetris before is just going to have that built-in expectation. So yeah, it's an important little detail. And a lot of things in games are like that. Like there's a lot of things that have to do with game feel that seem like minor details, but if you don't get them right, they can just really kind of mess things up. But yeah, we're at a good point here. So now we have automated drops, and when we manually drop, we reset those, and you can see here that we're stacking up pieces. And I think if we do stack up to the top of the board, I think we'll have a game over, because if you have a collision when your position's in the first row, that should game over. So I mean, we basically have a functioning Tetris game at this point. So just as a quick recap, we have successfully handled player movement, and we've handled collisions, and we've handled looking ahead and collisions into the existing pieces that have been placed, as well as going off the board. And we also just went through the slow drops and auto drops. And now we're going to take a look at doing the fast drop and the ghost. So the ghost is where you would land if you did a fast drop. And yeah, we're going to see what that looks like. So we may already actually have some of this because we've included a little bit of the fast drop state and checks as we've done this. So let's just check that out real quick. So if I hit space, does this drop to the bottom? So kind of, it drops, but it's not rendering. Let's see if it's actually there, if we collide into it. Okay, no, so it's just kind of disappearing when I do fast drop. So yeah, let's take a look at what's going on there. Okay, so now we're looking at fast drop. So I think the reason that the pieces are just disappearing if we try to fast drop with space is gonna come down to what's happening inside next board. So when we're figuring out the next board, we need to take fast dropping into account. And you can see, for example, here we're gonna do a reset of the player when we do a fast drop. And we need to do a few things to accommodate the fast drop and the ghost. So what we're gonna wanna do is we're gonna wanna place a ghost. And in order to do that, we're gonna kind of need to look ahead and see, essentially keep trying to move the piece down until we get a collision. And then we know that's the position where it should fast drop. So we're gonna wanna drop position, and we're gonna need to find that drop position. And to do that, we're gonna need a board, the position, and the shape we're dealing with. And this is so that we can, essentially just keep moving the piece down, down, down until we get a collision. And in order to find the drop position, we're gonna need a new function here. And again, that's gonna take the board, the position, and the shape. And we're gonna need to see what the max is, as well as the current row that we're looking at. So here we set up a max that is the total number of rows for the board minus the current position. And then we add 1 to that. And then we're gonna let our initial row that we're looking at be 0. And then we're gonna create a for loop where we basically just keep trying to place the piece and see if we get a collision or not. So we're gonna go from, we're gonna keep incrementing I as long as it's less than the maximum allowable here. And this is gonna look very similar to when we were moving pieces. So we'll start with our delta, and our delta is just gonna be however many rows ahead we're looking, but we're not gonna wanna change the column. So that's gonna remain 0. And then we're gonna call move player, which we already have, and store the result of trying to move that piece. And then we want to know whether we collided or not. So here's where we pull off the collided value from the result. So remember, this returns whether it collided or not, and it also returns the position. And then if we collided, we just want to stop. We want to get out of this loop. And if we didn't collide, we want to keep going through the rows here. We want to increment the row out here. And then eventually we want to return our position and override the row. So we're going to want to get, we will want back the same column that we're in, and then the new row. So that's right here. And I think you could potentially just make the index in the loop the row. I'm not sure. I'd have to try it out. But anyway, this should work for finding that position. So again, we're looking ahead, and we're looking ahead at all the rows and then trying to figure out where the collision would happen, and then place it like one, the row before that, basically. And we have to import move player from here, from player controller. So now we have our drop position using find drop position. And then with that, we need to add some new things. So we want to place a ghost on the board. And the way we're going to do that is we're going to transfer the ghost to the board at all times. And what we want to do is we want to say, if you are fast dropping, I don't know actually if this would matter, but basically if you're not if you are fast dropping, we don't render it as a ghost. If you are, we do add the ghost. And then we're transferring this ghost to the board here. And then basically, if you're fast dropping, we're going to consider that space occupied because we want to just immediately have it count as a collision. But if you're not fast dropping, we don't want to do that. We just want to treat it normally. So this is actually handling placing the ghost or the shape on the board. And then we also need to say in the situation when we're not fast dropping, we're gonna, and this is actually just a check we can put around this, but when we're not fast dropping, we also want to transfer the piece to the board. And if it collided, we want to mark it as a collision here. So we're doing two things. We're placing the ghost or the fast dropped piece, and then this is just placing the piece under normal circumstances. So here you can see it's transferring, it's showing a ghost piece down here. But it's showing up as the actual Tetramino, which is kind of interesting. This may have to do with this CSS, so let's take a look at that. I did something slightly different there. Oh, I see. So I haven't included the style, so I think this is working. I just don't have the right styles in here. So for the ghost, we need a transparency as well as a border. So now let's try that. So how does that look? So now our ghosts look a little more like we would expect, and then we can do fast drops. And the code for this does look a little odd. It's just because we have to either render one or two pieces depending on whether or not the ghost is visible or not. And then finally we'll need to handle actually like clearing rows. So when you get rows cleared, we'll want to update your score and the stats about the game. We'll want to get rid of the rows that were cleared, and then we'll want to insert new rows at the top of the board. So I think the only thing we have left at this point that's major is clearing the lines and updating the score. So if you recall, we're going to end up with lines that are cleared, and when we do, we want to remove however many of those we have. We want to update the score to reflect that and the level and the lines to the next level. And we want to insert new blank lines. So we're going to take a look at that real quick. So inside of our board where we're doing next board, we got next board here. So we're going to look at, after we've placed our pieces, we're going to check for cleared lines. So in here, we basically need to generate a blank line, because whenever we have a cleared line, we're going to want to use that as an opportunity to insert a new blank line at the top, at the beginning of the board. So here, I'm just saying for any given row that we have, because they're all the same size, generate a new row using the default cell, because that's basically what a blank cell is, or blank line. And then we're going to keep track of how many lines we've cleared. So initially it's 0. And then what we're basically going to do is we're going to take our rows and we're going to build up a new set of rows. And anytime we find a row that's cleared, we're going to get rid of it, and we're going to increase our line cleared count, and we're going to insert a new blank line at the beginning. So this is the code to do that. So we're gonna start with an empty array down here on 87. That's our accumulator. We're gonna take our rows. We're gonna reduce those rows. So initially this accumulator will be an empty array, and then for a row, we'll say, does every column in that row, is it occupied? And if it is, that means that's a cleared line. So we're gonna increase the lines cleared by 1. And then here, we're gonna add this blank row to the beginning of our rows. So anytime we have a cleared line, we're not including the cleared line in our accumulator, and we're putting a blank row at the beginning of the accumulator. And then otherwise, we're gonna push our new row onto the end of the list. So, you know, we're basically removing the cleared lines out, only holding on to the ones that aren't. And then for the cleared lines, we're adding a new blank line. And then at the end, we just return the accumulator. And then finally, we need to actually see if any lines were cleared. And if they were, we're gonna call add lines cleared with lines cleared. And I think technically we could just pass in this without checking it, but it's probably good to not call it if we don't need to call it. Technically you could do that check inside of here. So now we'll take a look at add lines cleared. And I think that's gonna be in useGameStats. And we initially had an implementation for this, but we didn't fill it out. So we wanna make sure we're receiving the lines that are being passed. And then what we'll do is we're gonna, sorry, just a second. We're gonna wanna update our game stats anytime lines have cleared. So we'll do set game stats. And what we're gonna do is we need to keep track of points. So here we're gonna have points, and those are gonna be our previous points plus 100 times however many lines we cleared. It's about the most basic scoring system you can do, but if you want to do more advanced Tetris scoring, that's kind of the place to, this is the place to figure that out. And then we want to get the lines per level from the previous game stats. That doesn't change. It's always going to be this value up here, lines per level. And then we need to figure out the new lines completed count. So that is your previous lines completed plus these new lines that you've completed. And then with that, we need to figure out if we have to increment the level or not. So we're going to make a level, and based on whether the lines completed is greater than the lines per level, we're going to add one to the level. Otherwise, we're just going to give you your previous level. And then we don't just want lines completed to keep incrementing and like indefinitely. So we always want it to be the lines to the next level, essentially. So we'll look at your new lines completed, and then we'll do the modulus of lines per level. And that way, if it's like 12, it's going to do, 10. It's going to basically go down to 2 because it's going to subtract the 10. So you got lines completed is going to get updated. It keeps trying to move it in. And then finally, we'll just want to return the new representation of game stats. So we'll do return level, lines completed, lines per level, and points. And those are all the same values as here. If you wanted to, you could try and set a lot of these things in line, but I prefer to just compute everything in advance and return the simplest thing I can at the end. So we'll save that. And I'm going to play this just a little bit so we can see how this is updating. But we should see the lines cleared changing for us. We'll put this over here. So there you can see the excuse me, the lines at next level is increased to, or decreased to 9, and we got 100 points. And then as we clear more lines, our points are going up and our lines to next level are going down. And then let's see. Our previews are kind of handy here too, because I can look at what pieces are coming up to figure out where I want to go or not go. And this is going to get messy for a little bit, but hopefully we'll get some column pieces here eventually. If not, we're going to be in trouble. It's kind of funny how long you can go without getting it. It's funny when you build a Tetris game on your own and you see this happening, because you always kind of figure it's like some weird quirk with how it was programmed, but it's usually not. And let's see if we can get some more column pieces. Looks like we got one coming up. I'm just going to stack that over there. I'm just going to shove this piece in here for now. I'm trying to get enough lines clear that we can see it go to the next level. I think we'll have enough. Let's see. Yeah, there we go. So we've moved on to level 2. We have 10 lines in the next level, and we have 1,000 points. So our previews are kind of handy here too, because I can look at what pieces are coming up to figure out where I want to go or not go. And this is going to get messy for a little bit, but hopefully we'll get some column pieces here eventually. If not, we're going to be in trouble. It's kind of funny how long you can go without getting it. It's funny when you build a Tetris game on your own and you see this happening, because you always kind of figure it's like some weird quirk with how it was programmed, but it's usually not. Hey, I hope you enjoyed that, and thanks for following along, and congratulations for making it this far. If you didn't code when you went through the video, I really encourage you to go back and try to code the game as we're going, or do it on your own. But you'll learn a lot better by actually writing out the code on your own. And if you don't have time to do that, at least download the project and try making some changes or tweaks to how things work. And I think the place we landed at the end of the project is a really good base for continuing to add more features. So you could do things like add special effects for when lines are cleared. You could do things like holding a piece. So if you don't want to use the current piece, like swapping it and holding onto it for later. You could evolve it into something that's more like Puzzle Fighter or Puyo Puyo or any of the kind of Tetris variants. But yeah, there should be a good base for kind of making any of those tweaks. So thanks again for watching. If you liked the video, please hit like. If you want to see more videos like this, hit subscribe. Let me know in the comments if this was useful. I really like making these longer videos, but I need to hear back from you all to know whether or not this is something you're actually interested in. And thanks for watching, and have a good day, and I'll see you in the next one.